Hi, welcome back. In today's video, we're going to talk about collections module. Let me illustrate what I want to talk about in an example. We're going to talk about counter. Here we are having a list of 6 strings here. So we are having a list named words. There are 6 strings in this list of ours. Okay, and we see that there are some strings repetitive. For example, apple appears 3 times, banana appears 2 times, and orange appears only 1 time. We would like to count the number of repetition that we are having for each string. For example, we would like to know how many times apple is shown, how many times banana is there, and how many times, for example, orange is there. In order to do that, we can use the counter. Okay, so we are going to use from collection, we are going to import counter. So counter class from built-in collection module is added into this program. So don't forget to have this header. We are going to have counter class from the collection module. Okay. Then we use that counter, and inside parentheses, we write down the name of our list. So the counter class, we are here using it to count the number of occurrences of each word in the words list. Okay, in the words list. So I repeat it, we are going to use the counter, and in parentheses, we write down the name of our list, and we are assigning it to count here. Okay. Then we are going to print this count, and then we are going to print the count and the apple element. What we expect to see in the output when I run this code is the following. So when we are having the print function to print us the count here, it works like a dictionary. So it has apple 3, banana 2, and orange 1. Basically, it says that we are having apple 3 times, we are having banana 2 times, and we are having orange 1 time. So it counts the number of occurrences for each of the unique strings, let's say. Actually, this counter takes an iterable and as argument and return the dictionary-like objects. For example, we are having the keys that are the unique elements like apple, banana, and orange. Then we are having the values that count how many times one element is repeated or appeared. Okay, so keys and values. Exactly, very similar to dictionaries, keys and values. So apple, number 3, 3 times it appeared. Banana, number 2. Orange, number 1. So this is how we are going to count the number of occurrences of each unique element. And then we are also using that count, and then we are having apple. So now when we write down the name of the count here, because we assign the output inside this to this count, okay? When we are having it here in the print function, and then we use the apple string, we are saying that, okay, tell me how many times apple has been appeared. Then it is going to type down the number 3. So if I want to know, for example, count how many times, for example, banana appeared. Okay, sorry, it's okay. So when I run the code one more time, we see number 2 is shown in the output. Why? Because we are talking about banana, and banana appeared 2 times. And when we talk about apples, we see apple appeared 3 times. So we can also talk about each unique element individually using this syntax, or we can print the whole thing and have something like a dictionary in the output saying that apple appears 3 times, banana appears 2 times, and orange appears one time. So this was a good example for the start of this section because we're talking about now the collection module. Let me repeat it one more time. So first of all, we are importing the counter class from the collection module. It's a built-in module, okay? Then we are having a list of strings here. Okay, here is my list of strings. We are having apple appearing 3 times, banana appearing 2 times, and we are having orange. So we are having a list of 6 elements or 6 strings, let's say. Then I use the counter class, and in parentheses, I write down the name of the word. So this counter class is going to create something very similar to a dictionary, okay? That is going to have keys and values. So keys are the unique elements, values are the number of occurrences of that unique element. For example, it says apple and number 3. So apple appeared 3 times, banana appeared 2 times, and orange appeared 1 time. And this is assigned to the count variable here. Then the name is count, but it's very similar to a dictionary, let's say. And then we are having the print of that count. It's a dictionary-like output. So we are having apple 3, banana 2, orange 1. And if we want to only talk about one unique element, we can have the name of the count, and then we are having apple, and the name of the count, the name of banana. So this way we are going to see how many times apple has appeared and banana has appeared. So it was a very interesting example. We're going to dive deeper into this concept in the following videos. Thank you. Hi, welcome back. In today's video, we're going to talk about counter class that is imported from the collection module. So here we are having a string called text, and we are assigning hello world string to text. Then in order to count the number of letters in our string, we are going to use the counter class. And in order to use the counter class, we learned that we simply write down the counter name with capital C, and in parentheses, we write down the name of the list, for example, or the string here in our example, and assign it to a new variable. So this new variable is a dictionary-like variable that is called char count. When we print this char count, we are going to see in the output something like a dictionary. So it says the counter, and then we are seeing L being repeated 3 times, O being repeated 2 times. So we check our string, yes, L, we are having 3L, we are having 2O. For example, we are having 1H, 1E. For example, one space is seen there, one W, R, and D. So in this example, we are having the example of a string, and we are using the counter to count the number of appearance of different letters. So when I have another string, for example, my string 1, now I'm typing down Reza Shahin. Let me use, okay, Reza Shahin. And we can have my string 2, and this is a Python course, for example, my string 3, and we write down, for example, hello from our Python class. Okay, then I would like to have the counter class to count the number of letters in each one of these strings. So I define a new, let's say, variable here. I write it down, for example, counter my string 1 equals, we use the counter keyword, and I write down my string 1, Then I print I print counter my string 1. Okay, so when I run this code now, we have the second output here being printed, that is talking about the number of repetition of letters in my string 1. So here we see, for example, A has been repeated 2 times, H has been repeated 2 times as well. So we see 2H, and of course we see 2A here. Okay, then we are having the rest of the string letters being repeated only once. And now if I have counter my string 2 equals counter my string 2, then I want to now print this one as well, my string 2. So if I run the code one more time, now we see that here regarding our second string, space being appeared 4 times. So one time here we are having space, then we are having one space here 3 times and 4 times. So space we are having it 3 times. We are having s 3 times here. So one s here, one s here, and one s here. Then T appears 2 times, H appears 2 times until the end. And finally, if I want to type down for the third one, we can have counter my string 3 and then print this counter my string 3. When I run the code, here we see that, for example, letter O has appeared 4 times, space has appeared 4 times. Then we are having the L being appeared 3 times, H 2 times until the end. So it was a very good example to see how we can use the counter class from the collection module to count the number of letters, unique letters, let's say, in different strings. Thank you for watching. Hi, welcome back. In today's video, we're going to have another example about the counter class from collection module. Here we are having a string called text. In our string, we are having this apple, banana, apple, orange, banana, apple, grape. Okay, so here if I use the counter directly to this text, for example, my text counter, and assign it to counter, then text, then I print my text counter. Okay, so let me comment these parts. Here I'm having a string, and this string is having this phrase, for example, apple, banana, etc. until the end, which is grape. Then I use the counter class to count the number of letters in this string and assign it to my text counter. Then I print my text counter. And it says A appeared 11 times, P appeared 7 times, space appeared 6 times, etc. But what if I want to count the number of words in this string? So apple, banana, apple, orange. I want to see how many times apple has appeared in this string. If I want to do that, I need to do the following. I need to use the split function to convert the string into list of words. Okay, so when I use the split function, I would have a list of words and assign it to word underscore list. Then I use the word underscore list in parentheses and call the counter class and assign it to count. Then I print count. So when I run the code now, we see apple appear 3 times, banana 2 times, orange 1 time, and grape 1 time. So it's a very good example. If you're having a string and you would like to count the number of letters in this string, you simply use the counter class, and in parentheses, you write down the name of your string and assign it, for example, to a variable name, for example, here my text counter, and print that. So you will have this output where your strings are, for example, a letter has been appeared 11 times. You're going to count the letters inside this string, the unique letters, let's say. However, if you have a string and you want to see how many times each word has been appeared, then you need to use the split function to convert the string to list of words. Then use counter for that word underscore list. And when you print that, you're going to have this output. Okay, let me illustrate another example. My string 1, for example, it is going to have, this is Reza Shaheen from the online Python course. And then we can have the teacher is Reza Shaheen, and this is my string. Okay, so my string counter, I assign it to counter my string 1. Then I print that, print my string counter. Okay, so if I run this code now, we see that in this string, we are having 13 times the space, we are having age 9 times, etc. until the end. So it is counting the letters, the unique letters. However, if I have the split function, we can have split my string, this is just a name, and assign it to the name of the string, which is my string 1 dot split function. So I simply write down the name of my string dot the split function and assign it to this split underscore my string. Okay, and then I use the, for example, here let me have a name. What can I have? For example, splitted, I would say, for example, equal to split underscore my string here. So I need to clarify this first. So splitted, I don't need that. I need to simply, yeah, split it. Then counter split my string. Okay. Here, when we have that and when I print splitted, I will have how many times each word has been appeared. For example, it says the word is appeared 2 times, the word Reza appeared 2 times, Shaheen appeared 2 times, de appeared 2 times, this appeared 1 time, from appeared 1 time. So if I want to review, we can have the following. We are having a string here, for example, and this is my string, and the name of my string is my string 1. Then I count the number of letters in this string. In order to count the number of unique letters in this string, I use the counter class. Then we are having my string 1 in parentheses and assign it to, for example, a new variable called my string counter. When I print that, it's as we mentioned, it's a dictionary like, so it has keys and values. So it says space 13 times, age 9 times, etc. But what if I want to count the number of words in this string? Okay, in order to do that, we are going to use the split function for my string 1 and assign it to a split my string. Okay, so we are splitting the words, we are converting the string into a list of words and assigning it to split my string. Okay, then I use the counter, and in parentheses I write down this name, split my string. So it's a list of words, and we are going to use the counter to count the number of appearance of each unique words. and we are going to assign that to splitted, and then we print the splitted. So we see that is, for example, appear 2 times, Reza appear 2 times, Shaheen appear 2 times. It's a very good example for you to see what you want to do with your string. If you want to have the number of letters being counted, the number of unique letters being counted, so you simply use directly the name of your string and use the counter. However, if you want to know the number of unique words that are appearing in your string, you first need to use the split function, assign it to a new variable, and that variable has a list of words for you, and write down the name of the list of words inside the parentheses for the counter, assign it to a new variable called splitted, then print that splitted, and we see in the output we are having it here. Thank you for watching. Hi, welcome back. In today's video, we are going to talk about default dictionary. We are going to import default dic here and then from the collection module. Okay, here we are trying to create a dictionary-like object where missing keys automatically get a value of 0. So here we see argument int, sorry. So argument int here is not a number. It's a function that returns 0 when called without argument. So we are ensuring that any missing key is given a default value of 0. Okay, and we are initializing a special dictionary where we are having keys that can be anything like apple, banana, orange, etc. And values are integers by default, but we can update them. So let me illustrate it with an example. So we are initializing here inventory, and when I print the inventory right away, we see that it's empty. We see that it says default dictionary, well, default dic, and then we are having here nothing inside of it. Okay, but if we want to add a key to this one, because we said that it's a dictionary, like it has key and value. Okay, exactly like a dictionary. So key and value. So if we would like to add a new key to this one, we simply write down the name of our dictionary inventory, and then we write down, for example, the key, which is apple, for example, in this example for us. Then we are having plus equal 1. It means that we are going to have apple, and apple is going to have a value 1. So the key apple is added, and its corresponding value is 1. So now when I print the inventory, we see apple and 1. Okay, now I can also add another, for example, key and value. For example, inventory, we can have banana, and then we can have plus equal 5, for example. Now if I print inventory here, when we run the code, we see that, okay, now in this part we are having apple 1 time but banana 5 times. Okay, so this is how we can have a dictionary like object to be used to give us a default value of 0. But let me illustrate another example. So with normal dictionaries, what we are doing now was not possible. For example, we are creating a dictionary, it's empty. And when I want to print the apple, for example, in this dictionary, it brings me an error. You see, it says that it doesn't exist, key error. Apple does not exist yet. But here, we were simply adding apple directly to our dictionary, and because we were using the default dic, it was considering a default value of 0 for it. But in our normal dictionary, we cannot do that. It's not possible. This is why we can use this type of default dic to help us to have a better output, and it's easier to work with. So if I want to create, for example, another one, I would say stockpile equals default dic, and I write down the int. So this integer, again, it's not a number, it's a function that returns 0 without argument. Okay, so it ensures that we are having any missing key is given a default value 0. Okay, so we are initializing keys with a default value of 0. Therefore, we're not going to have error when I talk about apple or banana. Okay, so this is how actually it works. Anything can be our key with a default value of 0. This is how it works. Then now I would like to have my stockpile and add, for example, mask to my stockpile plus equal 2. Okay, then I would like to add, for example, wizards, masks, wizards plus equal to, for example, 10. And then I print my stockpile here. So when I run the code, here we see we are having 2 masks and 10 wizards. This is a very good way to have a dictionary-like object to work with. You can add very easily your elements, and you can have the keys being added, and at the same time the corresponding value can be added to the dictionary, and you can see it in the output. And we showed that it's not possible to do it with the normal dictionaries. In the following videos we're going to have some more examples of default dictionaries. Thank you. Hi, welcome back. In today's video, we're going to have an example of default dictionary with lists. Here, we are creating an empty list with no argument, and this default dictionary list means missing keys will get an empty list automatically and are assigned to grouped words. Then we are having a list of tuples here called words, and we are having for fruit category, it contains apple, fruit category, it contains banana, vegetable category, it contains carrot, and fruit category again, we are having orange inside of it. So we would like to group the containers of the same category next to each other. So we would like to have fruits, then we have the apple, banana, and orange. Then we would like to have vegetables, then carrot. So we would like the fruits to be next to each other, and we don't want to have fruits 3 times. And then we would like to have carrot for vegetables. In order to do that, we need to first iterate through the words. Okay, and words is a list of tuple. Here we are having a for loop with 2 iterating variables, category and item. For each category and item that are in words, we are going to append the item to the corresponding category in grouped words. Okay, and grouped words was an empty list. We created an empty list with no argument here and assigned it here. And because we use the default dictionary, it means that when we are having some keys that are missing, they are going to get empty list automatically. Okay, so this is why we can assign it to grouped words here. So here I am iterating through the word list of my tuples for 2 iterating items. In each iteration, we are adding this item to its corresponding category in grouped words. And when all this has finished, we are going to have the print in the output. So when I run this code, we see the default dictionary class, this time list. Then we are having the fruit, apple, banana, and orange. And then vegetable, and then here we are having, for example, carrot, as you see it here in the output. Basically, in this part, we are saying that for the first iteration, grouped words, we are saying for example, for fruit, append, the first one is, for example, apple, okay? And let me have it in the code as well. Okay. So here before that, we were never having the category of fruit, but we are having it here because we were having a list, an empty list with no arguments. So now we are having the category fruit to be inserted and created for the first time in these grouped words. Then we are appending apple as one of the items of this category. Then in the second iteration, we are having grouped words. Then here we are having again fruit, and then dot append. Here we are appending banana. Okay. Then we are having in the third iteration, the previous one was the second iteration. Now in the third iteration, we are having the category vegetable. So we were not having this category so far. Now we are going to create it. And then we are going to append carrot to this category. And finally, we are going to have grouped words. Then here we are having fruit dot append in parentheses we are having orange. So we are appending orange to the fruit category. Okay. So what happens in the for loop is that we are going through the categories here and then the items here, and in each iteration we are appending that item to its corresponding fruit in grouped words that we created here. Okay. So apple is appended to the category of fruit, banana is appended to the category of fruit, carrot is appended to the category of vegetable, and orange is appended to the category of fruit. So now we filled the grouped words list. Then here we are simply printing the grouped word. So when I run this code, we see that for the first category, which is fruit, we are having apple, banana, and orange. And then we are having for the second category, vegetable, and we see that item that contains in vegetable is carrot. So this is how we can have our list here. So if I want to have another one, for example, we can have grouped sport here. Let me go up a bit. Yeah. Grouped sport here we could have, and then we can have default dictionary, and we are initializing it with list again. And we can have, for example, this example here, as you see, we could have, for example, cricket for India, cricket for Australia, cricket for England, and cricket, for example, for South Africa. And finally, we're going to close this list. So it's a list of tuple, and the category for all of them is cricket, and the item is different countries. So you see we are having, for example, India, Australia, England, and South Africa in the category of cricket. Then we could have other categories as well. So we could have, for example, soccer, we could have basketball, we could have different categories. So let me add one more category here. We could have, for example, soccer, and we could have, for example, France as its item, for example. So this is the category. Category is soccer. Okay. Now, if I want to have the iteration over this list, we again can have a for loop here. We can have a for loop for each category, an item in sport. We are going to append that item to its corresponding category for the grouped sport, and then we are going to print the group sport. So here we see that for cricket, we are having India, Australia, England, and South Africa. And for soccer, we are having France. So actually, this is how we can create our default list, a default dictionary with lists. Here we did that. Then we created a list of tuples called sports. Here we are having two categories, cricket and soccer. In the cricket category, it contains India, Australia, England, South Africa. And for soccer, we are having France only. Then, in order to transfer this list of tuples to our grouped sport, we need to iterate through this first. So we have two iterating variables because we're having category and items. So for each category and item in sports, here, this is the list of tuples, we are going to append that item in the corresponding category for the grouped sport. Okay, so for example, in the first iteration, we are going to have grouped sport, and the category is, for example, cricket dot append, and the item is, for example, India. Okay, then we are going to have grouped sport. We are going to have again cricket dot append. We're going to append Australia this time. Australia. Then we are going to have grouped sport. Then here we again have cricket dot append England. England. In the next iteration, we are having grouped sport. We are appending the South. Sorry, I need to add one code here. Append South Africa, then grouped sport. Finally, we are going to have soccer here. So we are having two categories, cricket and soccer. And finally, we are going to append France. So in this iteration, we see it here. We are appending different items to its corresponding category in the grouped sport India, in the cricket category for grouped sport Australia item is appended to the cricket category. For the group sport England, the same thing, South Africa, the same thing, and finally France is appended to the soccer category in the grouped sport. Then when we print grouped sport, we see in the output in the cricket category, we have India, Australia, England, and South Africa. And for soccer, we are having France. Thank you for watching. Hi, welcome back. In today's video, we're going to have a coding exercise with respect to default dictionaries. So we would like to create a default dictionary with set as default factory. Here, we are having default dictionary, and in parentheses, this time we are having a set. So this having set in parentheses creates an empty set when called with no argument. And this default dictionary set ensures missing keys start with an empty set. Okay. Here we are having a list of tuples. First, in the category A, for example, we're having apple, category A, banana, category B, apple, and category A, apple again. Okay. And now we would like to assign these categories and their corresponding items to our unique words. Okay. In order to do that, we need to have the iteration. So we use for loops for each key and value. These are two iterating variables. For each key and value in entries, which is our list of tuple, we are going to add the value to its corresponding key for the unique words. Okay, so when we are iterating, for example, unique words. The key is A, for example, and we are going to add its corresponding value, which is apple. Okay. In the next iteration, we are having unique words. The category or the key is, let's say, A. Then we are going to add the banana. Then we are having unique words. There we are having the key B, and we are adding apple. Finally, we are having unique words. And here we are in the category A, and we would like to add apple. Okay. But this last iteration is not going to work. Why? Because here we created a set. Okay, so this default dictionary set ensures missing keys start with an empty set. And if you remember, one of the feature of sets was the fact that they do not accept repetitive elements. Duplicate elements are not allowed in sets. And already in the first iteration, we added apple to A. So here we cannot again add apple to A. So we have banana to A. So banana is not duplicate, so it's inserted in A. Apple in B, it's possible because in category B, this is the first time that the apple appears. Then in category A, we would like to append or add the item that is apple. We cannot do that because we are dealing with sets, and although we will have this iteration, but we are not going to have a second apple in category A. Finally, we are going to print these unique words that we created here and we filled here in the for loop. When we run the code, in the output, we see the set. And then we see in the category A, we are having banana and apple. In category B, we are only having apple. So let me have another example. For example, we can have unique sports. Okay, and the default dictionary is set. So we can have entries to equal to, for example, here we are going to have different categories. We could have, for example, for soccer, we can have France. Then for soccer, we can have England. For basketball, we can have USA. Then for soccer, again, we can have, for example, we can have, for example, Italy. Then for soccer, again, we would like to have France again. And finally, I would like to have the basketball, then France here as well. Okay. So here is my entry. Then in order to fill my unique sport, I am iterating with two iterating variables where I'm iterating through the entry 2, and then these are two iterating variables. So in each iteration, we are adding the value to its corresponding key in unique sports. Okay. So for example, here we are having the unique sport. So it's soccer, and its value is France. We are having unique sports. it is soccer in the next iteration. Then we are having England. We are having unique sports here in the third iteration. Then it is basketball, and we are adding the USA. Then we are having unique sports. We are again having soccer here. We are having soccer here, and we are adding Italy this time. We are adding Italy. Now we are having unique sports. In the next iteration, it will be soccer. And we are adding France. We are adding France, but it's not going to be inserted. It is not going to be inserted. Why? Because we already added France to the category of soccer, and this France is duplicate, so we cannot add it one more time. And in the last iteration, finally, we are having unique sports. We see basketball, and we add France here as well. So these are the iteration. In the first iteration, we add France to soccer, we add England to soccer, USA to basketball, Italy to soccer. So far, all of them are unique. Then we want to add soccer to France to soccer. We see that France is already inserted, so we are not going to insert that because we are following set rules. We are having empty set when we created unique sports. Then we are having France added to basketball, okay? And then we print it. So we are having two categories, soccer and basketball. And in the first category, when I run the code, we see we are having France, Italy, and England. France, England, and Italy. Then in the basketball, we are having France and USA. And as you see, we are having France in basketball and USA. So for the category B, we are having one France and one USA. And for category basketball, sorry, we are having two elements, France and USA. And for category soccer, we are having France, Italy, and England. And the duplicate of the France is not inserted in the soccer category, as we can see it here in the output. So this is how we can use the default dict here and use set as the default factory. So it is going to create an empty set when called with no arguments, and it ensures missing keys start with an empty set. Then we had a list of tuples. We iterate through that, and we add the elements into the unique words that we are having here. Thank you for watching. Hi, welcome back. In today's video, we're going to talk about named tuple. So we're importing named tuple from the collection module. Okay. Here we're defining a named tuple called point with two fields x and y, and we are assigning it to a variable called point. Then we are here creating an instance called p of the point with x equals 3 and 4. Okay. Why x equals 3 and 4? Because we are creating an instance of point. Okay. And then the point has x and y. So 3 equals x and 4 equals y here. And in order to access the values, we can use dot notation. So we use the print function. We will have p.x and comma p.y to access these 3 and 4. And also we can print the entire named tuple instance. So when I run this code, for this line, p.x and p.y, we are having numbers 3 and 4 that we assigned here. Then when we are creating when we are printing the entire named tuple instance, we see that it says point coming from here, and x equals 3, y equals 4. So this is how the name tuple can be created. But why do we need name tuple and we're not using regular tuple here? Let me clarify it. So using the regular tuple, it's a bit hard to read. For example, when we are having a tuple called point, we are having two elements, 3 and 4. And when we want to print them, we simply print the element with index 0 and print the element with index 1, which is 4. So it's we sometimes we need to think, okay, what is point the index 0 of the point tuple, and what about this one? So you need to remember that the index 0 of the point tuple means x, and index 1 of the point tuple means y. So we need to remember it. This is a bit hard when we are having like 200, 300, maybe 2000 lines of code that you need to remember. For example, in certain specific tuples, the first element is x and the second element is y. Therefore, it's easier for us to use named tuple over the regular tuple, because as you see it here, we are using the named tuple and we are simply importing the class from the module, and then we are having a class, a named tuple, sorry, with x and y. And when we are creating an instance of the point, we see that 3 and 4 are x and y because we are simply using p.x and p.y. So when we call p.x, the first element is called. When we write p.y, the second element is called. So we don't have to worry about the thing that we may not remember the first element of which tuple is x, for example, or the second element of which tuple is y, etc. So it's clear and readable, and you don't need to remember index positions. This is the first reason why named tuple are very good. Secondly, we have regular tuples that are mutable, so we can modify them. For example, here I'm having a tuple called point. It has two elements, 3 and 4, and we can reassign the whole tuple. We can have 5 and 6 now to be assigned to the same tuple. However, when we are having named tuple, they are immutable, so we cannot modify them. Once we create uh, an instance of that named tuple, for example, with x equals 3 and y equals 4, we cannot reassign the x to be 5 now. They are immutable and we're going to have errors. So this protects data integrity for us. It's very important. And for example, here, let me create another one, another named tuple. We can have point 2, x and y. Then here I create an instance of the point 2. Here, instead of 3 and 4, I would say simply 5 and 8, for example. If I want to access the elements, the values, we can use the dot notation as we discussed. So I write down print, then I say the name of the instance, which is p2.x and p2.y. So when we have this, we expect to see 5 and 8 in the output. And here we can also print the whole name tuple instance to have it completely printed. So here, when I print p.x and p.y as before, we see 3 and 4. Then when I have the second instance p2.x and p2.y, 5 and 8 are printed in the output as you see it here. And then we entirely print the named tuple instance, which is x equals 3 and y equals 4, which are these ones that are assigned to our instance. And finally, when we are printing the entire p2 name tuple, we are having the x equals 5 and y equals 8. So this is how actually we can use name tuples, and we discussed about the advantages of name tuple over the regular tuples. Thank you for watching. Hi, welcome back. In today's video, we're going to talk about the application of name tuple. For example, here we learn how to store and access latitude and longitude with clear feed names instead of indices. Here we are importing the collection module, and we would like to work with name tuple. First of all, we define a name tuple for GPS coordinates. For example, we would like to store a GPS coordinates that we got from the Google map, let's say. And simply using the name tuple, we can have a coordinates with its latitude and longitude. Okay. And then, for example, we are going to create an instance of that coordinate, and we are naming it NYC or New York. Then we are going to here, when we are creating an instance here, we are inserting the latitude and longitude respectively. And finally, if we would like to access it, we can write down the name of the instance that we created and then put a dot and then the latitude and dot, the longitude. Therefore, when we use the print function, we see these two numbers in the output. So instead of writing, for example, NYC for the index 0 and NYC for index 1, now we are using nyc.latitude and nyc.longitude. It helps to improve the code readability because it makes sense. For example, now that I see, okay, here we're talking about the NYC, which is probably New York, and its latitude. And here we are talking about NYC longitude. Okay, we are talking about a coordinate. So it's understandable for someone who does not develop this code, who didn't develop this code. It's understandable for that person as well, most probably. Instead of having, for example, in the output, for example, NYC 0 and NYC1. When we are having this in the output, probably we need to have a comment somewhere saying that, for example, I'm using NYC0 to have the latitude being printed out in the output and NYC1 to have the longitude being printed out in the output. However, if I use the indexing like this, most probably we need to insert comment. For example, these are talking about the latitude and longitude coordinates imported, for example, from Google Maps for New York City. Okay, so probably we need to provide a comment so other people, when they are reading our code, they can understand that what we're talking about. It's way easier to use latitude and longitude, so it improves the code readability. Here, let me have another example. For example, I could have coordinate 2. I use name tuple, and then have I have the, for example, coordinate 2. Then we are having, for example, the latitude and longitude here. Okay, so this is another name tuple that we are defining for our GPS coordinates. And this time, when I want to create an instance of this coordinate, I, for example, type down Montreal. So we are going to talk about the Montreal, and then we are having coordinate 2, and we can have a number, for example, 45.5017 and minus 73 dot whatever, just a number. Okay, Then, in order to access that, we simply print and I write down the name of my instance that I created, which is Montreal, then dot, and then latitude, and with a comma I separate it from the longitude, so I write down the name of my instance again, and this time put a dot and I type down longitude here. So when I print that, we should see the coordinates in the output again, like we inserted here. So we see that we can provide coordinates, GPS coordinates, and use a name tuple to have the latitude keyword and longitude keyword, making our code more readable. And then we are creating an instance of that name tuple, and using that instance, we can have access to latitude and longitude that we created earlier. Thank you for watching. Hi, welcome back. In today's video, we would like to represent a student record using name tuple. Here, we are importing name tuple from the collection module, and we are defining a name tuple for student information. And we are having the name to be student. In this name tuple, we are having three elements: name, age, and grade. So we see that it's possible to have more than two element in our name tuple. So for example, if we are having a coordinate example, we can have two elements, x and y, representing the x coordinates and y coordinates. However, we can have more than two elements in our named tuple. For example, we can have a student record here where we store name, age, and grade of one student. Then we would like to create two instances of this name tuple. So S1 and S2, and we need three pieces of information in order to create our instance. For example, Alice for the name, 21 for the age, and A for the grade. This is the instance of the first student. Then we are having the instance of the second student, where we see that Bob, 22 years old, and with the grade B. But how can we access these values? In order to access these values, we can simply write down the name of our instance, dot name, to have the name of the first student being printed, and then to print the grade of the first student, we can write down the name of the instance, which is S1, then dot grade. Okay. And if we want to have only one piece of information about one of the students, we write down its corresponding instance, which is S2, for example, and the age. For example, now we are going to have the Bob's age being printed out in the output to be 22, as we see here. And for the first print, we are having Alice, and the grade is A. So if I have another instance, for example, here, student, I write down, for example, Reza. The age is 25. Let me write it with capital S. Yeah, okay. And the grade is A. Now I can use the instance S3 to access the information of Reza. For example, I can have the name, I can have the age, I can have the grade, all of these things I can have, or we can print it only one piece of information. For example, I just want to know the grade of Reza, so I simply write down print s3.grade. So I created a new instance here for our name tuple. The name is Reza, the age is 25, and the grade is A. Then I use the S3 instance to access the name, the age, and the grade of Reza. I'm printing it in the output. And also, if we want only the grade of Reza, we can do that. We can go ahead and use the instance and then dot grade to simply print A for us in the output. We can, of course, add some message here so it's easier to understand. We could say the grade of Reza, or for example, third student, then we print it. So when I run the code now, we see this message, the grade of Reza, third student, A. And here also we are having Reza 25A. We could have different messages being shown. So the name of the student, then we could have, for example, the age of the student. And then here again, we could have the grade of the student. So when I run the code, it's easier to understand now. So I'm typing the name of the student is Reza. Okay, let me put a comma here and here because we are having Reza, but there is nothing between Reza and the new sentence. So now we are having this, the name of the student Reza, the age of the student 25, and the grade of the student A. So this is how we can use name tuple for student record system. Thank you for watching. Hi, welcome back. In today's video, we're going to talk about how we can use name tuples to store employees' data in an organization or in a company. So I'm having my named tuple here, and I use the employee name, and there are 4 elements here, as you see. The first one is ID, the second one is name, the third one is department, and the fourth one is salary. Then we are creating 2 instances, E1 and E2. In E1, we are storing information of John Doe, whose ID is 101, and he's from the engineering department, and his salary is 80,000. Then we are having the instance 2 being created here, and his ID is 102, and we're talking about Jane Smith, and this person is from the HR department, and the salary is 60,000. Now that we stored the data in our named tuple using our instance, we would like to access it. In order to access it, it's very easy. We write down the name of the instance that we created, then we put a dot, and then we write down the element name. For example, here is the name, then the department. So now it's going to print us the name of the first person and the department of the first person. And this line helps us to have the salary of the second person because we are using E2. So when I run this code, we see John Doe Engineering, and 60,000 is the salary that is printed for the salary of the second person. So we could say here the salary of the second employee is, so this message could help us to have a nicer output. For example, here the salary of the second employee is, sorry, there should be a space there, employee is 60,000. And here we could say, for example, the name of the first employee is, and here we could say, for example, the department of the first employee is. So when I run this code, we see these messages helping us to understand the output better. So the name of the first employee is John Doe, the department of the first employee is engineering, and the salary of the second employee is 60,000. This is how we can use named tuple to store, for example, information regarding our employee in a company. And this was a good example to have, for example, 4 elements in our named tuple. Thank you for watching. Hi, welcome back. In today's video, we would like to use named tuple to represent colors. We would like to store color values in red, green, and blue format. Here is my named tuple. called color, and it has three elements: red, green, and blue. Then we would like to define some colors using instances. So the first instance called white, the second instance called black, and the third instance called red. For example, for the color white, we have the values in red, green, and blue format. And the value for this instance is for red is 255, 255 for the green, and 255 for the blue. Okay, so the elements in the white that gets different values are 255 for red, green, and blue, all of them. Then the second instance is created. Let me write it down. Maybe it's second instance, first instance, third instance. Okay, so the second instance is created from the color named tuple, and it has values equal to 0 for red, green, and blue. Then the third and last instance is created here, and for the name tuple color, it has only value for the red, and for the green and blue has 0 values. Okay, so this is just an assumption, just an example. We are just creating, don't uh, be confused with the numbers here that we are creating. We're just making an assumption here to create an instance. The important thing is that this is the instance. We can say ins1, ins2, ins3 instead of having white, black, and red. Okay. Then in order to access the elements that are stored in instance 1, we write down white.red because this is this red that we are talking about and not this red. Okay. Then we are having white.green and white.blue because we learned that we write down the name of the instance dot the name of the element, which are red, green, and blue in these cases. Okay. So when I run this code, we see the output is exactly like this one. So if I copy this and paste it here, okay, and instead of white, I write down, for example, black. Now we are going to see the output for instance named black for different elements red, green, and blue for our named tuple. And we expect to see 3 zeros in the output. Exactly, we see it. Then if we have it now for the red, and the red. So when I run this code, we expect to see first red to be 255 because we created the instance with these numbers, and then 2 zeros. So when I run this code, we see 255. So this first red is our object here, our instance here that we created. The second red is the element inside our named tuple. This is the most important part about this example, this coding exercise. Then we have the red again, dot green. This is the green. And then we are having the red again and dot blue, which is here. Thank you for watching. Hi, welcome back. In today's video, we would like to integrate the concept of named tuple with functions. Here, we are having our named tuple called a rectangle. It has 3 elements: width, height, and area. Okay. Then we are having a function called getRectangle. And whenever we call this function, we need to have 2 arguments. Then this function is going to calculate the area of the rectangle based on the passed arguments that are width and height respectively. So area equals width multiplied by height, and basically this function is going to return a rectangle named tuple with width, height, and area. So the output of this function is in the format of our named tuple. So this is how a function actually trying to return multiple values in a structured way. But how are we going to use that? Here, before we learned that if we want to have, for example, if we want to create an instance, we name the instance, for example, instance1 equal to rectangle, the name of our named tuple, and in parentheses, we were having, for example, number 5, 10, and the area. If we wanted to calculate it ourselves, we would have written, for example, 50. Okay. But instead of creating an instance like this, being equal to the name of our name tuple and then in parentheses having these three elements, okay, instead of doing that, my instance now equals to a call of function, and we are calling this getRectangle function with two values, width and height, and this function is going to return what we were supposed to have. Okay, rectangle 5, 10, 50. It is going to return rectangle, the name tuple, width, height, and area. All of them, the function has access to it because the width and height, we call the function with those numbers, so 5 and 10, it already has. And for the area, it just calculated the area here, okay? Width multiplied by height. So instead of writing the instance like this, we write down the instance, it is equal to a call-off function, and that function is going to return what we need here, okay? Then after creating our instance, we are going to print in the output saying that, okay, the width is the name of the instance dot the name of the element, like always, the height, the name of the instance, like and the name of the element, and the name of the instance, and then the name of the element. So when I run this code, we see it says width 5, height 10, and area 50. It's a very good example to see how we can integrate named tuple with a function. For example, here let me create another instance. So instance2 get rectangle, and with these values, for example, 10 and for example 15. So when I have this one, whenever we are creating the instance, right away we are calling the function. So compiler starts executing this part, calculating the area and returning the name tuple that needs to be equal to my instance. Then I use the same line here, but instead of the rect, which is the first instance, I write down the name of my second instance, which is instance2. So when I run the code, this time it says width 10, height 15, and then area 150 based on the calculation that the function did for us. Thank you for watching. Hi, welcome back. In today's video, we are going to talk about how to convert a name tuple to a dictionary. Here is the name tuple called person. Then we are having the fields, or let's say the elements. The fields are name, age, and city. After that, we are creating an instance of the person named tuple, and the instance has this information: Alice, which is the name, 30, which is the age, and then the New York, which is the city. Okay. Now we created our instance, and now we would like to convert this to a dictionary. In order to do that, we simply write down the instance name dot underscore ASDICT, this code, underscore ASDIC, and with empty parentheses, and assign it to a new variable name, for example, person dictionary. Okay. Basically, this function that we're talking about here, returns an ordered dictionary where field names that are name, age, and city are keys, and values that we're having here are from the named tuple. Okay, so basically what it is going to do is the following. It is going to have, for example, name. It is going to have name Alice. Okay, then we are going to have age 30. Then we are going to have city, and then New York. Okay, so we see that as we defined here, the fields in our name tuple that are name, age, and city are keys in our dictionary name, age, and city. And these name tuple information are our values here. You see, Alice is the value for the name key, 30 is the value for the age key, and also New York is the value for the city key. So this function is going to do this for us. Convert the name tuple instance to a dictionary using this function. And simply we are going to print %dictionary, and when I run this code, we exactly see what we expected here. We see that name, age, and city, the fields of our name tuple, are the keys in this dictionary, and then the values are Alice, 30, and New York. Actually, this function is a built-in function in Python for named tuple instances. And basically, this method is useful when we need a dictionary-based data access. In order to have a dictionary-based data access, we are going to convert the named tuple instance to a dictionary simply using this function. Thank you for watching. Hi, welcome back. In today's video, we are going to create a named tuple called car, and it has three fields: brand, model, and year. We learned that named tuple are immutable, so we cannot modify them, but we can use the underscore replace function to create a modified copy of the instance for the name tuple. So here is my name tuple called car, three fields. Then we are creating an instance of the car name tuple, which is Toyota, Corolla, and the year is 2020. And we know that we cannot modify that, but we can create a modified copy. In order to create a modified copy, I write down the name of the instance, dot, then underscore replace. In parentheses, we are having the year equal 2023. So instead of 2020, I would like it to be 2023. And all these modified copy is assigned to new car. So now I print my car and new car. So when I run the code, we see that the original instance, which is my car, has the Toyota Corolla year 2020, but the modified one is the Toyota Corolla year 2023. So this is how we can use the underscore replace function to have a modified copy of the original instance. For example, I would like to now to modify the brand, for example. For example, I write down new car2, it's the name of my instance from, and it is assigned to be equal to my car dot replace. So we are going to assign the brand BMW to this instance instead of Toyota. Okay, so we are creating a new instance. We are replacing the new brand. So Toyota is not assigned to the new instance. BMW, however, is assigned, but for example, the model is Corolla still, and the year is 2020. Okay, so when I run the code, it makes no sense to have a brand and with the model Corolla, so we can have also this modification as well. So new car, here we could have, for example, model equal x5, for example. Okay. So when I run this code, we need to print the instance as well to see it in the output. Okay. Now we are having the original instance that we created here, Toyota Corolla 2020. We see it. Then we created a modified copy of the first instance, and instead of the year 2020, we assigned year 2023 and assigned it to new car instance. So we print new car, we see it here, Toyota Corolla and 2023. And finally, we created another new instance called new car 2, and we replaced the brand and the model, and the year is still the same, so it's 2020, but the brand is now BMW, and then the model is X5. So we see when we print this object, in this instance, we see that brand is BMW, the model is X5, and the year is 2020. So this is how basically we can create a modified copy of our name tuple in Python. Thank you for watching. Hi, welcome back. In today's video, we are going to talk about deck. They are double-ended code. And in Python, a deck is a list-like container that allows fast appends and pops from both ends, from the beginning and from the end of the deck. Okay. And there are a few examples why we need to use deck in our codes. So there are faster performance for insertion and deletion as compared to lists in Python. They are efficient for first in, first out queues and also useful for last in, first out system. And they have a fixed length queues for recent data, and they support fast rotations. But what these things mean, we're going to dive now into the code to see what are these things that we are talking about. In order to use deck, we are going to have the deck being imported from the collection module. Then we are creating one. Here is the name of my deck, which is DQ, and these are the elements 1, 2, 3, 4, and 5. And this deck is created and assigned to DQ. Basically, I am printing out the initial deck in the output. As you see, the initial deck, we see 1, 2, 3, 4, and 5. But how can we append some elements into our deck? In order to append from right, we can simply write down DQ append, and for example, now I would like to append number 6, and using this code I can append number 6. So when I run this code, we see after appending 6, deck looks like something like this. So 1, 2, 3, 4, 5, 6. 6 is added on the right side of my initial deck. So here is the code. DQ, the name of my deck, and dot append. In parentheses, we write down the value that we want to be added to our deck, and simply I'm printing it here. But what if we want to append one element from left? In order to append from left, we write down the name of the deck dot append left. In parentheses, we write down the value. Now I am appending one value from the left to my deck, which is 0. The value is 0. When I run this code, you see that after appending 0, this was my previous deck. Now you see 0 has been added from the left hand side. So previously we learned how to add 6 from the right side. Now we are adding 0 from the left side. So this is how we can append either from right or from left. It's very easy and it's very fast. And in order to pop from right, we simply write down DQ, the name of the deck, dot pop, and empty parentheses. So when I run, you see that we are popping from the right. So the 6 is being removed as the last element of my deck. So 0 to 5 is being created there. So 6 has been removed, or let's say we are popping from right simply by using the pop function. And in order to have pop from the left hand side, it's possible to simply write pop left. Okay, so when I run this code, now this is the last version of that we had. After that, we did the popping from left, so 0 has been removed as well. So 0, we don't have it. 6, we don't have it anymore. Now we are having a deck like this: 1, 2, 3, 4, and 5. Then, in order to extend our deck, we can have the extend keyword and then the numbers that we want to be added at the right of our deck. So 7, 8, and 9. So when I run this code, on the right side of our deck, we'll see 7, 8, and 9. So here, after extending at right, we are having 1, 2, 3, 4, 5. So far, it was the previous version. And then 7, 8, 9 are added to our deck here. Okay. Then in order to extend from left, we can again have the keyword extend, but from left, so extend left. Then we write down the numbers: -1, -2, and -3. So when I run this code, we expect to see from the left to be extended. So we are seeing -3, -2, -1, then 1, 2, 3, 4, 5, 6. 6 we don't have, 1 to 5, and then 7, 8, 9. So here is extending from left hand side. We are having -3, -2, -1, and then 1, 2, 3, 4, 5, and then 7, 8, and 9. So when we are extending from left, we are having the lower number being shown on the left part, which is -3 in our case here, okay? And then we are having the rotation on the right hand side. So if we want to rotate from the right, we simply write rotate and we mention by 2. So by 2 values and elements, we would like to rotate them. So 2 values or 2 elements, we want to rotate them. Here you see this was my previous version. When we rotate from right 2 elements, these 8 and 9 are not here on the right side, but they are on the left side. So when rotating from the right side, these two numbers we mentioned because we want to rotate 2 elements. In parentheses, we put the number 2. So we see that these 2 last numbers are assigned to the left side of our deck here. You see 8 and 9 are there. So if we want to rotate from the left side, we can have rotate -2. Now I want to have 2 elements from the left side. So I write down 2 because I want to rotate 2 elements. And I write -2 because I want it to be done from the left side. So when I run this code, these 2, 8, and 9 are back in the last version to where they were. So we are rotating from left and putting them on the right side of our deck here. Then we can create a new deck with a maximum length. For example, here we are having a deck that has 3 elements, and we mentioned that the maximum length of this deck is 5. So now it has 3 elements only, and we print this deck underscore max. So we see that, okay, it has 3 elements, and the maximum size of this deck is 5. Therefore, it has 2 remaining elements to be added. Okay, in order to add new elements, we are adding 40. Let me uncomment them one by one. So now I try to append 40 on the right side of deck max. When I run the code, you see 40 is added there. Okay, now if I uncomment this, we will see 40 and 50 is added. So 10, 20, 30, 40, and 50. And maximum length is 5. So we are having 5 elements. But if I want to append another number, what would happen? So if I add another number, when we are having the maximum number in this deck because the maximum length is 5 and we are already having 5 elements there. So if I add a new number, it is going to remove this 10 number. This number 10 is going to be removed. So when I run the code, you see now 10 has been removed and 60 has been inserted. If I add another number, 20 will be removed and another number will be inserted here. So in this video, we saw what the deck is and how we can append and pop elements from the right side or from the left side. And also we learned that they are faster, they're having faster performance for insertion and deletion as compared to lists. And we saw that we can have a fixed length size for our data. In this example, we were dealing with a fixed size, and we saw how we can simply have the rotation of our elements. We rotate two elements from right, so it means that we took the last two elements, insert them in the beginning, and then we can take the first two elements and put them on the end of our deck. So it's very easy. And we are going to have some coding exercises to see how the first in, first out would work and how last in, first out would work. So let me review the code. Here is how we created and initialized our deck. Here is how we appended an element from the right side, how we appended from the left side, how we popped from the right side, let's say to delete an element from right side, and how to do that on the left side, how to extend it. We extended and we added these three numbers, how to extend from left, how to extend from right, how to rotate from right by how many elements. So here 2, you can say 5, 3, whatever. How to rotate from left, we must use the minus and then the number of elements like 2, 3, 4, 5. How to declare and create a deck with maximum length and how to print that, and the policy regarding appending new elements to one deck that has a maximum size that we learned about in this video. Thank you for watching. In the following videos, we are going to have some coding exercises with respect to this topic. Hi, welcome back. Here we are going to discuss first in, first out concept for deck. Here we are initializing a deck called queue. Then we are appending three elements to the queue, so A, B, and C. So this is the first part, the creation part, okay? This part is the appending part, so we are appending three elements to our queue, and then printing part, okay? Printing. Now we would like to remove one element from left, and then we want to print the output. So because we are following the first in, first out concept, whatever that comes in first, it is going to be removed first. Therefore, we can use the pop left function to remove the first entered element in this queue. Let me print this once here. So when I print our queue here, let me comment these two lines. So when I run the code, we see that here we created the deck, we appended three elements, and we printed it. So A, B, and C. So first of all, we added A, then we added B, and then we added C. Now the first in was A. So if we want to have first in, first out policy, A should be removed. In order to remove A, because it's the first element from left, we simply use the pop left function in order to remove that. And as you see here, we are removing the element A, and if I print the whole deck, you will see that it will have now elements B and C. So this is how actually we can have first in, first out policy in deck. Thank you. Hi, welcome back. In today's video, we are going to talk about last in, first out policy in deck. So here is my deck.
We are creating it. It is called stack, and we are appending 3 elements to it. So X, Y, and Z are appended to the stack. Then we are printing the stack. So when I run the code, we see the original stack. X, Y, and Z are 3 of them. All of them are added. So now the last in element was this Z, and we want to have the last in first out. So the last element that entered, we want to take it first. Okay, so Z we inserted at last, and we want to start removing from Z. Okay, in order to start removing from Z, we simply use the pop function that is going to remove from the right hand side where the last inserted element is stored. So we use the stack.pop with empty parentheses, and then I print the last element that is being removed, which is Z here. And finally, I print the full deck in the output, and we see now we are having X and Y and Z indeed has been removed. So here in this example, we learned that we can do the last in first out using deck. Thank you for watching.
Hi, welcome to this video. In today's video, we're going to talk about ordered dictionaries. So an ordered dictionary works like a regular dictionary, but the important thing about the ordered dictionary is that they remember the insertion order of keys. So an ordered dictionary is a dictionary that remembers the order in which keys were inserted into this dictionary, and they are very useful. For example, they can maintain the order. Unlike the older version of Python dictionaries, ordered dictionary keeps a key insertion order. It's very important, particularly if we are talking about if you're working with JSON processing or, for example, configuration files, and these are the situations in which the order is very important. So when the order is very important for us, it's better to use the ordered dictionary. They are ideal for this situation, and they support move to end function, which helps us to reorder the elements. So in the following videos, we are going to do some coding exercises with respect to different aspects of ordered dictionary, so you see that how we can use them, implement them, and how useful they are. Thank you for watching. Hi, welcome back. In today's video, we are going to dive deeper into the concept of ordered dictionary, and we're going to learn how to declare them and how to work with them in a few coding exercises. First of all, in order to work with them, we need to import ordered dictionary from the collection module in Python. Then, in order to create an ordered dictionary, we need to write down the name that we want to have for our ordered dictionary. Then we are assigning it to order dict in empty parentheses. So the name of the order dictionary equals then the keyword of order dictionary and with empty parentheses. Now we created our order dictionary, sorry, with the name OD. Okay, and now we would like to have its element. For example, we can have for the element with the key A the value of 1. As we remember, we mentioned that it's like a normal dictionary with different features. Because it's like a normal dictionary, it has keys and values. So for example, it has the key 1, value 1, okay? So for example, if you're having it in parentheses, then we are having key 2, key 2, value 2, for example, etc. until the end. So different keys, different associated values. Here is our first key, which is A, and its value is 1. Then we are having another key, which is B, and its associated value is 2. And we are having a key that is C equals to an associated value equals to 3. And then we are going to print our order dictionary, which is called OD. So when I run this code and we come here, we see the output here. We see that we are having the order dictionary being printed. So it says A1, so the second key, the second associated value, B and 2 and C and 3. So this is how actually we can have our order dictionary being created and declared. Now let us do some more coding exercise with respect to order dictionary. So in order to access one particular element, how do we do that? For example, if we want to print only the second element of our order dictionary, how do we do that? In order to do that, in order to access a specific element in an order dictionary, we simply write a message, for example, the value for the key B, so it's clear in the output. We can trace it easily. Then we are having the name of our order dictionary. Then we simply write down the key in quotes. So it is going to get the key, that specific key, and then from the OD order dictionary. So when I run this code, we see that it says value for key B is 2. And this part is our message. You see value for key B is 2. This is the message that we wrote to be printed. And this is the part we can access the value of the key B from the OD order dictionary. Okay, so this is why 2 is being printed, because we assign number 2 to it. But if I, for example, want to have another value for another key, we can simply write down, for example, value for key C colon order dictionary, then C. Okay, so this is how we can have our order dictionary here. Let me comment this part for the moment. Okay, now I'm trying to show the value associated to key with key C here. And in order to access that, simply we write the key name in the code here from the order dictionary called OD. And we expect that in the output we see number 3 as well. So when I run this code, in the output again we see value for key C equals 3. So this is how actually we can access different elements of an order dictionary. Now let us do another example. What if we want to update the values? So here for the key A, we are having its associated value equal to 1. However, what if we want that 1 to be updated and be equal to 10, for example? Simply, in order to do that, on the left-hand side, we write down the name of our order dictionary. In our case, it is OD. Then we are having the key name that we want to work with in the code. So A is there, and it equals number 10. Now, this way, we are trying to update the value associated with the key A from the ordered dictionary. When I run this code in this part, we are printing again the full order dictionary to see what happens after updating A here. So I go down, we see that after updating A, this message is shown. Then it says A is 10, B is 2, and C is 3. So you see here A equals 10, while A was equal to number 1 previously. So this is how we can update the value of A. Here also we can, for example, update another value. For example, here I would like to update the value associated with the key B. For example, I write down again the name of my order dictionary and the key, which is B here, equals 20. So now I am assigning number 20 to the associated value with the key B from the order dictionary called OD. Okay, then we print it after updating B, and we are going to print the full order dictionary. When I run the code here in the output, we see that, okay, after updating B, A is 10, B is 20, and C is 3, and you see B is 20 and B was equal to 2 previously. So this is also how we can update the order dictionary. Now, what if we want to move one element to the end? In order to do that, for example, we would like to move the key B from the order dictionary OD, and for doing that we need to use move to end function, move underscore to underscore end. So using this function we can assign the key B to the end of the order dictionary OD. After doing that, we simply print after moving B to end. We see that here we are having the print of the OD. So when I run the code, we expect that now the key B should not be the second key, but the last key. Okay, so we come here, we see that after moving B to end, we see that A equals 10, C equals 3, and then B equals 20. Previously, we were having A, B, and C, but now we are having A, C, and B. So this is how actually we can move one key to the end. And okay, now what if we want to move, for example, now A to the end? So if I want to move A to the end, again, I write down the name of my order dictionary, then I use the function move to end, and then here I write down, for example, A. This is how I can move A to the end, and then I simply print the order dictionary and the message saying that after moving A to end. So after moving A to end, we are printing the full order dictionary, and this was the way to send A to the end. For example, in order to send the key A with its associated value to the end, we write down the key A, then we write down move to end, and we use the move to end function to do that. In parentheses, we write down the name of the key, and in the beginning, we should start with the name of our order dictionary, which is OD. Then I print the full order dictionary. So when I run this code, we see that it says after moving A to the end, we see previously it was like this. So A, C, and B. Now we sent A to the end. So A is there and in the end. Then B is in the middle, and we start with C here. Okay? Because A was the beginning and C was the second one. Now A is sent to the last one, and that C, which was the middle one, is now the starting point of our order dictionary. Then, for example, what if we want to send one key to the beginning? So let me now send A to the beginning again. Here, I'm updating this. For example, here, I want to send one key of our order dictionary to be the first key. Here, you see that C is the first key. Now I want to have A as the first key again. How to send it to the beginning of our order dictionary? In order to do that, we simply write down the name of our order dictionary, then the function name move to end. But this time in parentheses, we need to have two arguments. The first argument is the key that we want to send to the beginning of our order dictionary, and it is separated by a comma from the second argument, and the second argument simply says last equals false. This last equals false will help us to send the key A to the beginning of the order dictionary OD. And here I'm printing out after moving A to the beginning, then we are having the OD. So when I run this code, we see the output after moving A to the beginning, we are having the order dictionary A again is the first key, then C, and then B. While in the last version, in the previous version, we were having A as the last key. Now, thanks to the move to end with the last equals false argument, we are having A key being the first key in our ordered dictionary. What if now we want to send B, for example, to be the first ordered dictionary key? In order to do that, for example, I can again write down the name of my order dictionary, then move to end, and then we are having, for example, B here, last equals false, and then we are going to print it. So now I want the key B to be the first key using this keyword of the order dictionary OD, and we are using the move to end function. So now B will be the first key of the order dictionary OD using the move to end function and the last equals false argument. After that, we are saying after moving B to beginning, we are printing the order dictionary, and you see in the previous version, B was the last key. Now, thanks to the move to end function with the last equals false argument, we are having B as the first key. So B 20, A 10, and C 3. So this is how actually we can move one key to the end or the beginning. So how about removing or deleting an element? In order to delete an element, we write down the del keyword, the name of our order dictionary, which is OD, and then the key that we want to be removed. Now I'm removing the key A from the order dictionary OD, and then we are printing the order dictionary one more time. So when I run this code, we see that after deleting A, order dictionary looks like this. We are having B equals to 20, and the key C has its associated value 3, and A, which was 10, is now not included in our order dictionary because we just removed it. Then we would like to compare a normal dictionary with an order dictionary. Here we are asking the compiler, we are having two uh, normal dictionaries and we're comparing them. So it has three, each of them is having three keys and their associated value. For example, X, Y, and Z. X is 100, Y is 200, and Z is 300. And we see that Z is 300, X is 100, and Y is 200. But in the second normal dictionary, we are changing the place of the dictionary. For example, Y was the second key, now it's the first key. X was the first key in the first dictionary, and it is now the second key in the second dictionary. And we are asking the compiler to see our normal dictionaries equal, and we are assigning dictionary 1 to be equal to dictionary 2, and we want to see if the result of this is true or false. So when I run this code,
It says, are normal dictionary equal? The answer is true. So the compiler sees these two normal dictionary to be equal. However, when working with order dictionary, we are having two orders dictionaries here. So the order dictionary 1 and the order dictionary 2. So X, Y, and Z, 100, 200, and 300. Then Y is 200, X is 100, and Z is 300 in the second order dictionary. And we see that the keys are the same. The values are the same. However, the place where we are having Y in the first one and the second one is different. And also the same logic happens with the X here. Okay. And we are asking the compiler to see are ordered dictionaries equal, and we are asking the compiler this using the order dictionary 1 equals order dictionary 2. So when I run this code, the answer is false. So these two order dictionary are not identical because the order in which the keys are inserted is very important in the order dictionary. This is why the compiler does not see them to be equal to each other, So in this video, we did some coding exercises here. We learned how to create an order dictionary and assign keys and their associated values to an order dictionary. We learned how to access different elements of an order dictionary, for example, the key B, the key C. Then we learned how to update one key, for example, in an order dictionary. We're assigning a new value to a key that we already declared above. Here we are updating A, and also we were updating B here. So we were updating A with 10 and B with 20. Then we learned how to move one key to the end of our order dictionary. So for example, using the move to end function, we learned how to move key B to the end of the order dictionary. And also here we learned how to move the key A to the end of the order dictionary using the move to end function. Using the same move to end function, we can send and move, let's say, one element to the beginning of our order dictionary. Here is the move to end, and now we are going to work with two arguments. First, the name of the key. Second, we write down last equals false. So this can help us to send or to move the key A to the beginning of the ordered dictionary. Again, we did the same with the key B. After that, we learned how to delete an element from our order dictionary. For example, we want to delete the key A with its associated value. So we learned that we can use the del keyword. Finally, we compared two normal dictionaries with each other to see if compiler sees them to be equal if the order of the keys and their associated values are different in these two normal dictionaries. For example, the normal dictionary 1 was having X and Y as the first two elements, but the second normal dictionary was having Y and X. So in this case, because they are normal dictionaries, the compiler sees them to be equal. However, when we are working with ordered dictionary, we see that this little change will lead to having two different ordered dictionary, and the compiler says when we are asking it, okay, are they equal? It says no, they are not equal. So in this video, we talked about ordered dictionaries and different operations that we can do with them. Thank you for watching. Hi, welcome back. In today's video, we're going to review how we can create an order dictionary with 3 key value pairs and print all the elements. And we are going to then learn how we can have access and print a specific keys value. So first of all, when working with order dictionary, we need to import them from the collection module. Then we are having the creation of order dictionary. We, for example, want to name our order dictionary to be OD. Then it is equal to order dictionary with empty parentheses. So this is how we create an order dictionary. Now let's have our elements, keys and their associated values. So the first key is name. It is associated with the value Alice. The second key is age. It is associated with 25. The third key is city, and it is associated with string New York. So we are having three keys that are name, age, and city. Then we are having three associated values, which is Alice, 25, and New York, respectively. In order to print the ordered dictionary, we can simply use the print function. We write down order dictionary message, and then we write down the name of our order dictionary. So this is basically how we can have our order dictionary completely being printed. We are having the key name. Its associated value is Alice. We are having the key age. Its associated value is 25. And we are having the key city, and its associated value is New York. Then we are having the access to a particular key in our order dictionary. For example, we use the print function to have access the value for the key age. So for the key age, the value is 25. Now, if we want to print 25, we can simply write the following: the name of the order dictionary, then we are having the name of our key here, and when I run this code, we see that number 25 is being printed in the output. So in this video, we reviewed how we can create an order dictionary, how we can have different elements, the keys, and their associated values. Okay. Then we learned how we can print the order dictionary, and finally we reviewed how we can have access to specific value for a specific key. Thank you for watching. Hi, welcome back. In today's video, we are having another coding exercise with respect to ordered dictionary. We would like to have a tracking task completion order system in which we are having a list of, for example, a to-do list, and we want to mark all the tasks to be incomplete in the beginning and then update the status of, for example, one particular task and have it to be completed. And then we see how we can do it in order dictionaries. So first of all, we import the order dictionary from the collection module. Then we are creating an order dictionary for tasks. We call it tasks. So this is the name of the order dictionary equals to order dictionary keyword in parentheses, okay, empty parentheses. Then we are creating different elements. So we are inserting different elements. The first element with its associated value, the second key, let's say, with its associated value. So this one is the second element in total. The third key and its associated value. So task 1 to 3, and all of them are having the status incomplete because it's just the beginning of our work. So these are the tasks that we want to have, and it's a to-do list, and these are the status. All of them are incomplete. Then we are, first of all, we're saying that, okay, print the initial task list, and we are going to print that. So when I run the code, we are seeing that, okay, task 1 incomplete, task 2 incomplete, and task 3 incomplete. So we created an order dictionary with the tasks being incomplete in the beginning. Then we do some work, for example, and now the task 2 has completed. Now we need to mark it as completed. So we are assigning the completed let's say, status to the task 2 from the tasks order dictionary. This is how we can do it. So we write down the name of the order dictionary, we then write down the name of the key, and it is equal to the status which is completed. Then we are saying that after updating the task list, sorry, here is, okay, now after updating the task list, we are printing the full task ordered dictionary, sorry, to see how it is. Now we see that task 1, it is still incomplete. Task 2, however, is now completed, and task 3 is incomplete. So order dictionary are very useful because we can have, for example, a track of tasks in a to-do list and check if one task is completed yet or not. If yes, we can update it easily, and then when we print again the order dictionary, we can simply trace to see how many tasks are labeled incomplete and how many tasks are marked to be completed. Thank you for watching. Hi. In this video, we're going to talk about chain map. So a chain map is a data structure, again from the collection module, that allows multiple dictionaries to be treated as a single unit. So it groups multiple dictionaries together while maintaining their individual identity. So we are going to have multiple dictionaries in one unit using the chain map in Python. For example, when you perform lookups, chain map search through the dictionaries in order and returning the first match it finds. So why do we need to use chain map? The first reason is that they are having efficient lookup. So instead of merging dictionaries, which creates a new dictionary, chain map allows us to have efficient key lookup across multiple dictionaries without copying data, for example. And then we can have overriding values. It helps to manage different layers of data where later dictionaries can override values from earlier ones. It's very important. Then we can have managing defaults. For example, it is useful for managing configurations with default values can be overridden by user settings. Okay. And finally, it's because they're having the scoped variables. So they are very useful in scenarios like variable scopes in programming, like local and global, or built-in scopes. In the following, we are going to have some coding exercises with respect to chain maps. So we're going to learn how we can create them and how we can work with them and how we can access different dictionaries that are included in a single chain map. Thank you for watching. Hello everyone, welcome back. In today's video, we are going to have some coding exercises with respect to chain maps. So a chain map, we discussed that it is going to combine multiple dictionaries. So first of all, when we want to work with chain map, we need to import them from the collection module. Here we are having three dictionaries, dictionary 1, dictionary 2, and dictionary 3. The first one has two keys with their associated values. For example, dictionary 1 has a key A with value 1, a key B with value 2. Dictionary 2 has two elements again. The value 1 is the 20 for the key B, and the key C has the value 30, and also the dictionary 3 has only one element with the key D and the value 40. So these are our three dictionaries. Now we would like to create a chain map with dictionary 1 and dictionary 2. In order to do that, for example, we want to name our chain map to be CM, and we simply use the chain map keyword, and in parentheses we are having dictionary 1 comma dictionary 2. And this is going to basically use the first two dictionaries to create a chain map and assign it to CM. And a CM is a merge, let's say a combination of these two dictionaries. Then we are printing the initial chain map. So CM is being printed in the output. Here we see that initial chain map is A and B. These are the two keys from the first dictionary with their associated value. And then we are having the second dictionary now here, which is B and C with their associated value. So the dictionary 1 was having A and B and C was for the second dictionary. Okay, so A and B from the first dictionary and B and C from the second dictionary. So as you see here, this is the first dictionary and this is the second dictionary. They are combined in our chain map. So if I want to create another chain map, I can write down chain, for example, CM2. This is the name of my second chain map. Let me write down 2. Then I use the chain map keyword to, merge these three dictionaries, dictionary 1, dictionary 2, and dictionary 3. And after that, we write down this message, initial chain map 2, and we're printing the CM2, which is the name of our newly chained map. And when we print the CM2, we expect to see AB, BC, and D. So when I run the code, in the output, we see AB, this is from the first dictionary, BC from the second dictionary, and D from the third dictionary. So this is basically how we can create a chain map from different dictionaries. But then, what if we want to access the values inside this chain map? In order to do that, we need to use the name of the chain map, which is CM, and then we simply write down the name of the key that we are looking for. For example, now if we want to have the value associated with the key A from the CM chain map, we write it like this. So it is going to find it in the first dictionary. Then you see that here in the first dictionary, we are having a key called A, so the value 1 is going to be printed. Then we want to have this B being printed, so we are going to have the name of the chain map and the name of the key. So this B is going to be printed, so this B overrides this B. Okay, so we can print this B in the output. And finally, if we want to, for example, print the value associated to key C, which is 30 here, we can simply write down the name of the chain map and then the name of the key. So when I run this code, we can see in the output we are having value of A is 1, value of B is 2, and value of C is 30. 1, 2, and 30 is being printed. So 1, 2, and 30 is being printed in the output. Also, if we want to, for example, access the values of the second chain map, we can do the same. So we use the print function and we simply write down value of, for example, D, value of D, then a comma CM2, then we simply write down D. So it is going to print the value associated with the key D from the CM2 chain map. Okay, so CM2, if you remember, we created from all three dictionaries, dictionary 1, dictionary 2, and dictionary 3. So when I run this code, we see here value of D is 40, which is indeed true. So this was how we could create a chain map
from different dictionaries, and after that we could access the values from different keys. But how do we update these values? How do we update these values? So these values, in order to be updated, we simply write down the name of our chain map, which is CM here, then the name of the key, which is B, then it is assigned to a new number. So B, again, it is going to affect only the first dictionary, and B was initially 2, so now we are updating its value to be 100. So now we are updating the value associated to the key B from the CM chain map, and we are saying that after updating B in the chain map, we are printing the full chain map to see how it works, and also we are printing the first dictionary also to see how it can have impact on the first dictionary as well. So the first dictionary is A1, B2, okay? So when I run the code, I come here. After updating B in the chain map, we see that A is 1, B is 100, and the rest of the chain map remains the same. So the initial chain map was A1, B2, so now A1, B100, and the second dictionary in our chain map was B20 and C30, so B20 and C30 remained the same. Also, after that, if you remember, we tried to print, so we tried to print our first dictionary, which was this one, so A1 and B2, and we see that the modification that we did for the key B in the chain map also impacted the dictionary 1, because we see that dictionary 1 is now A1 and B100, which was initially A1 and B2. So this is how actually we see that updating a value associated to a key from a chain map can also directly impact a dictionary. Now, what if we want to add a new dictionary, for example? In order to add a new dictionary to our already existing chain map, we can have a new chain map, for example. Simply, we write down the CM, the name of our first chain map. Then we use the new child function. This is the function name that we need to write down, and then we are associating it in parentheses with a new dictionary, which has one element only. The key is E, and the value is 50. And all of this is assigned to a new chain map, which is called cm underscore new. So when I run the code one more time, we come back here, we see the new chain map with extra dictionary. So we are having the new dictionary here with key E and its associated value 50, A1, B100, and B20, and C30. So this is basically how we can create a new chain map using an already existing chain map with adding a new dictionary. Again, here we could have, for example, a new chain map from the second chain map, because the second chain map that we created was this one. This is the second chain map using all these three dictionaries, dictionary 1, dictionary 2, and dictionary 3. So this is the chain map 2. So we can have, for example, chain map 2, and then we are going to add a new dictionary to it. So we are creating a new chain map from the chain map 2. We are using the new child function to add the new dictionary and insert it, and then assign it to our new chain map 2. And the dictionary that is being added is having one key, which is E again, with its associated value, which is 50. Then we are printing it out saying that new chain map with extra dictionary 2, and then we are printing it in the output. So when I run this code,
we see that this is the original second chain map was A1, B2, B20, and C30, and then D40. Okay, so this is our second chain map. Or we see that here when we are having the first dictionary with the key E and the value 50 is being added there. Okay, so this is actually how we can have it uh, in the output. This is how we can create a new chain map from an already existing chain map by adding a new dictionary. So let me comment this part because there will be a lot of things in the output, so it's a bit hard to manage everything and not get lost easily. So now we are going to learn how to convert a chain map to a regular dictionary. Okay, in order to do that, we are using this keyword, and in parentheses we simply write down the name of our chain map, which is CM, and this is the dictionary that we are creating. So this is merged underscore dictionary is the regular dictionary that we are creating here from the CM chain map. Okay, and this dictionary keyword is going to convert the chain map to a dictionary and then assign it to merge dictionary. And then we are going to print out the merged dictionary. So when I run this code, it says the merged dictionary is B, C, and A. Okay, we are not having E because we didn't work with the CM new. We worked with the CM, so the initial chain map we worked with. Okay, and you see it here, the merge dictionary is having 3 elements only. So A, C, and B, and we are having one B. If you remember in the chain map, we were having A, B, and C, but because it's not possible to have duplicates key, it is going to take the first B that it encounters from this dictionary. So it is just simply keeping one B, which is the first B that it encounters. Then this all the unique, let's say, keys are kept. So then C and then A is there. So this is how we can merge dictionaries. And finally, if we want to delete, for example, one key from our chain map, when we have the del keyword, the name of the chain map, and then the name of the key, we can remove the key B from and its associated value from the CM chain map, and it is going to again affect the first dictionary. So here we see that after deleting B in chain map, we are having, so this was the initial chain map. Just remember, we are working with the CM always and not with the newly generated dictionaries here. Okay, so the initial chain map was A1, B2, B20, C30, but here after removing B, we are having A1. So A1 is only there, A1, B2, B2 is removed. You see it here. But the second B from the second dictionary, which was inside our chain map, B20 and C30, remains the same. But this A1, B2, this B part is removed. So only A1 is there. And we also see that it affects our dictionary as well because we are trying to print our dictionary as well. So this was the only original dictionary 1, A1 and B2. However, after removing B from the chain map, we see that it also has impact on our dictionary 1 because we see that the dictionary 1 after deletion is only A1. So this B part has been removed. So to wrap up, in this video, we learned about chain map and we learned how to work with them, how we can combine multiple dictionaries into one chain map, and how we can use a chain map keyword to merge these two dictionaries into a unique chain map. Then we learned how to access the values of a chain map. We write down the name of the chain map and then the key that we want to access its associated value. We learned how to update values of a chain map. We learned how to add a new dictionary into an already existing chain map using a new underscore child function. Then we learned how we can convert a chain map to a regular dictionary, and we learned that only unique keys will be kept. So if we are having two keys with similar and identical name, in the regular dictionary, we are going to have only the first key that it encounters. For example, if we are having 1b equals to 20, and 1b equals 100, we are going to take the 1b, which is equal 20, because this is the first b that we encounter, in fact. Then we learned how we can delete one key and its associated value, and we saw that it not only has impact on the chain map, but also has impact on the original dictionary as well. Thank you for watching.
Hi, welcome back. In today's video, we are going to have some coding exercises for chain maps. So here we would like to have managing configuration settings. So a chain map can be used to handle configuration settings, where user-defined setting override system defaults. Okay. So here, first of all, we need to import chain map from the collection module. Then, for example, the default configuration of our system is the following. We're having a dictionary that is having 3 elements. So theme is the first key, font size is the second key, and language is the third key. So for the key theme, we're having its associated value, which is light. For the key font size, we are having its associated value, which is 12. And for the language key, we are having its associated value, which is English. Okay, so this is the default configuration of our system, for example, and displayed in a dictionary. Then we can have a user defined setting. For example, this is the when you buy, for example, a cell phone, this is the default configuration that comes with the cell phone when you turn it on. But then it asks you some questions that you can customize the configuration setting of your cell phone. For example, you prefer dark theme, or you prefer to have a larger font size, or even if you want, you can have another language. For example, you don't want to have the default configuration of your cell phone to be English, you want it to be French, German, Chinese, etc. So it depends on you, and you want to have a customized configuration. This is what we call user-defined setting or user configuration. In this case, for example, cell phone that I bought comes with a light theme and with the font size of 12 with the English language. However, I would like to have my font size to be bigger, and the theme, I don't want it to be light, I want it to be dark. Therefore, I have my own defined configuration. So I would like to have a dictionary to present my data. So when I enter the data, it can be presented in a dictionary, for example, inside the cell phone. It is it is posing some questions. Based on my answers, it is, for example, preparing a dictionary with keys and the associated values. So the key is here theme, I want it to be dark, and the font size, I want it to be 14 instead of 12. Then using a chain map, we can combine the user configuration and the default configuration and assign it to a variable that is holding our chain map called config. Then what is going to happen is the following. This is the default configuration. When the user defined configuration is there, we're going to have the user defined configuration overriding the default configuration. Okay, so the theme is now dark. It's overriding the theme light, which was the default setting. And the font size is now 14, which was the default size was, for example, 12. So now that we have it on a chain map, we are first putting the user configuration and then the default configuration because we want the user configuration to override the similar keys there. So this key is shared between two configurations. Therefore, I want this theme to override this theme, which is the default one. Now, when we print, we see that, for example, we want to print the theme from the config chain map. This is the keyword, and this is the key, let's say, of the chain map, and this is the name of the chain map. Therefore, when we run the code, we see that the theme is dark because the user preference overrides the default preference. Okay? But then when we talk about the font size, we again have the key font size from the config chain map. And when we print this, we see that in the output, we have the font size of 14, which is the user preference that is overriding the default setting and configuration. Finally, when we want to discuss the language in which the system is presented, for example, we write down the key language from the config chain map. However, here we see that the language remains the same. It's English because the user did not define any customized configuration apart from the English, which was the default setting. So this is why we see that the language remains the same. However, if we wanted to have a different language, it would have been something like this. For example, I could say language. Then we could have, for example, French here. Okay. So now that I added a new key to the user preference, the user configuration, this language overrides the default language, which is English. So now when I rerun the code, I expect to see French in the language because now it is also customized. So this is how we can have a managing configuration setting, for example, for a cell phone or for a laptop. When we buy it, it has a default configuration, but we are going to customize it. And this can be done through dictionaries and more particularly when they are combined. So we are having a chain map and the user preferences is going to override the default setting. Thank you for watching. Hi, welcome back. In today's video, we are going to have a coding exercise with respect to chain map in Python. So we're going to talk about variable scope resolution. We're going to have three different scope resolutions, one for local, one for global, and then the last one for built-in. So a chain map can be used to simulate variable scope resolution in Python where local variables override global variables, which in turn override the built-in variable. Let me illustrate it with this example. First of all, we're importing the chain map from the collection module. So here we are having the built-in scope. So the built-in scope, this is the default values that we are having here. These are the default values in this built-in scope. So we are having the max value 100 and we are having the mean value, which is 0. But we want to have global and local scope as well. So in the global scope, we are going to have the max value, which is 50. So when we are having the global scope with the same key, which is the max value, we are going to have this let's say variable, this key of this dictionary overriding this key, okay? Because we are having global that overrides the built-in scope, and we are having a local that is going to override the global and the built-in scope. So for the local, we are having the max value here. So the max value 25 is going to override the global scope key max value, which was itself overriding the max value from the built-in scope. And here we also have the current value keyword. So the current value keyword only shows up here in the local scope. For the global scope, we are having only the max value, which is going to override this built-in max value, and which is going to be overridden by the local scope max value. And also we are having a mean value that shows up here only and has the value 0. So now we would like to have the priority of the local scope, then the global scope, and then the built-in scope. In order to have this, we are using a chain map to combine these three dictionaries. So the local, global, and built-in, and the chain map name is the scope. So now if we are going to have the max value being printed in the being printed out in the terminal or in the output, we write down the key called max value and the name of our chain map, which is scope. Then when we are having this one, we are going to have the number 25 in the output from the local scope. Why? Because we are having a dictionary, a chain map, let's say, containing all these three dictionaries. And because first we are having the local scope dictionary there, it is going to use the first max value that it sees. So this is 25 that it is going to be shown in the output. So max value key from the local, from the scope chain map. Then we are going to have the mean value from the scope chain map. So mean value, we know that it's not going to be in the local scope because we don't have it. In the global scope, we don't have it. In the built-in scope, we have the mean. So the 0 is going to be printed in the output. And finally, we are having the current value, which is 10, and it is only defined in the local scope dictionary. So it is going to print number 10 in the output. So when we run the code, we see the max value is 25, exactly the max value, the value for the max value keyword from the local scope is printed in the output. Then we are having the mean value, which is 0 here. And then we are having the current value, which is 10 as we expected. Let me first print our chain map here. This is our chain map. So I'm going to print scope. So when I run the code, we see the scope in the printing in the terminal. So first, because we are having for the chain map to create it, we combine first the local dictionary, then the global scope dictionary, and then the built-in scope dictionary. So this is the local, this is the global, and this is the built-in dictionary, that all of them are combined to create our chain map, okay? So this is why when we are having the max value key being printed from the scope chain map, this is the max value, this is max value, and this is max value. So there are three keys with max value name in this chain map distributed in three different dictionaries. However, the first one that the chain map sees is going to be the output. So this is the first max value that the chain map finds when we call it. So, and its value is 25. So this is why 25 is printed in the output. So this max value overrides this one and this one. Then we would like to have the mean value. So the compiler starts from left. The mean value, do we have it here? No, here, no, here, no, here, no. But here we are having it, mean value. So the mean value is being printed in the output. Then we are having the current value. So here it's not there, the current value is here, so 10 is printed in the output. So the first one that the compiler sees as we move forward from left is going to be printed in the output based on the name of the key. So for example, the key called max value from the scope chain map. So this is the scope chain map. The max value, the first one is 25. This is why 25 is printed in the output. So this is a good example of how variable scope resolution can be performed and can be taken care of using chain maps. Thank you for watching. Hi, welcome to this video. In today's video, we're going to have an introduction to heap and heap queue in Python. So a heap is a special tree-based data structure that satisfies the heap property. For example, in a mean heap, which is the default in Python's heap queue, the smallest element is always at the root. And in a max heap, the largest element is always at the root and can be simulated in Python. So Python provides the heap queue module, which implements a binary heap using a list. It is efficient for priority queue operations, finding the smallest or largest elements, and optimizing algorithms like shortest path. And we use them because getting the smallest and largest element is very fast in Python using heap queues. In the following videos, we are going to have some coding exercises and have some figures of discussing the tree-based data structure and see how we can implement heap queue to have our results in the root. For example, the smallest one or the largest element in the root. Thank you for watching. Hi, welcome to this video. In today's video, we are going to have a coding exercise to understand the mean heap concept. So in a mean heap concept, the smallest element is always at the top of the tree. So here, in order to use the heap queue, we need to import it first. Then we would like to have a list called nums, and this list has 7 elements: 3, 1, 4, 1, 5, 9, and 2. So these are the elements of our list called nums. Then in order to convert this list into a mean heap in which we can see the smallest value at index 0, we are going to use the heap queue and then the heapify function. So this is the heap queue that we are using, that we imported in the Python. Then using the heapify function, we are going to convert it into a mean heap. So basically, a mean heap means that the smallest element is at index 0. Okay? In order to have a mean heap, we can use the heapify function, and in parentheses we are having the name of our list that we want to convert it, which is nums. After doing that, we can simply use the print function to print nums for us. So when I run this code, in the output we see mean heap is 1, 1, 2, 3, 5, 9, and 4. Just remember that heapify function is not going to sort our list for us. Okay, it is going to only move the smallest element to be at index 0. So you see that the smallest element in this list was 1, and now 1 is index 1, the index 0. So this is how we can actually see how heapify function can convert our list into a mean function and has its first element to be the smallest element in the previously mentioned list. For example, in nums, we were seeing that number 3 was the first element, but in the output, we see that number 1 is the first element, which is the smallest element in our mean heap. Thank you for watching. Hi,
Welcome back. In today's video, we are going to learn how we can add one number to our heap. In order to add a number to our heap here, we are using the heap push function. So we write down the heap queue, which is our imported library here in Python. Then we use the heap push to push a new value to our heap, and then we need to have two arguments. So the first argument is the name of our list, original list, let's say, that we converted it to a min heap. So this is the name of our min heap, and then the number that we want to add to this uh, min heap that we are having here, nums. Okay, so when we are adding this, after that I print the nums here. So when I run the code, we see that the min heap was originally look like this: 1 1 2 3 5 9 and 4. Now we are adding number 0, so now it starts with 0, and because it's the smallest uh, element in this min heap, it is going to be at index 0. For example, here, if I had number 10, for example, when I run the code, we see that after adding 10, 10 is inserted at the end here. But because we are adding a number that is smaller than the other numbers, which is 0, and we are having a min heap, 0 is going to be the first element since it's the smallest element in our min heap. This is how the logic would work. So in order to add a number to our heap, we simply write down the heap queue, then heap push. Heap push will help us to add it. And then in the parentheses, we are having two arguments separated by a comma. First, the name of the min heap, and the second is the value that we want to add to our heap. And after that, we are going to simply print it out. Okay. Then what if we want to remove the smallest element in our heap? Here, in order to do that, we simply have the, again, heap queue dot, this time heap pop. So for adding a number, we used heap push function. For removing the smallest element, we are going to have the heap pop function, and in parentheses, we write down the name of our min heap. And all of these are assigned to smallest variable. Okay, so it is going to give us the value that is going to remove, and it is assigned to smallest. So here I'm just simply printing out the smallest element that has been removed. And then after removal, we are printing out our min heap one more time. So we see that here was the previous version of our min heap, which was starting from 0. Then we mentioned, okay, remove the smallest element, which is 0. So we remove that, and 0 comes from here. Okay, remove the smallest element, and smallest is being printed, which is this number 0. Okay, so this function helps us to remove the smallest element using the heap pop function. From the min heap nums, we are going to remove the smallest element, and the smallest element is assigned to a variable called smallest. And in order to understand which number was the smallest element in that min heap, we assign it to smallest and print it out, so we know that which element has been removed. Then we are simply printing heap after removal. So heap after removal looks like this, because in the previous version we were having this and it had a 0, but here we removed the 0 and we see that we have no 0 in the after removal. So in order to review, in order to add one element to our heap, we simply use the heap push. In the first argument, we write down the name of the heap that we are having, and the second argument is the value that we want to add. Okay. after adding, and this is basically it. So this is how one value is added. So if the added number is the smallest number in the heap, it is going to be placed in the first place. So you see that 0 that we added here is the smallest number in the heap. This is why 0 is the first element. But if I enter 10 here, for example, instead of 0, it's not going to stay as the lowest element. So the lowest element is 1, so the mean heap is going to start from 1, and 10 is added at the end. Okay, so if I add, for example, 5 here, again we see 5 at the end, because 5 is not the smallest number, so the mean heap is going to start with the smallest value. And just note that it's not a sorted heap. Okay, it's only a mean heap, meaning that it is going to start with the smallest element. This is what it's going to do. Then we learned how to remove an element, remove the smallest element using the heap pop function, and the name of the heap is inside the parentheses. And in order to find that what is the element that we are removing, we assign it to a variable called smallest, and we print out the smallest here in the output. Also, after the removal, we print the heap to see now how the heap looks like. So we see that 1 is the first element in our heap here, because here we were inserting number 5, and number 5 was the last element. So here we remove the first element, so we had 2 number 1, and now we remove one of them, and we see only one number 1 still is there, and we are having it right there. Thank you for watching. Hi, welcome back. In today's video, we would like to have a coding exercise using heap queue for priority queues. Here we are importing the heap queue module in Python to use it. Then we are creating an empty priority queue here for our tasks, but it's in a form of a list, and we name it tasks. So this is our priority queue. Then we would like to add tasks to this priority queue. In order to add tasks, we know that we can use the heap push function in order to add tasks to our heap queue using the heap queue module to our priority queue. But one thing to mention here is that we can give priority to different tasks. For example, here we would like to push back to this priority queue, but we want to not only add the task that needs to be performed, but also its priority. So its priority is 2. Write report. So this is with priority 2. Priority 1, which is the first thing that we need to do, is fixing the bug. And after fixing the bug, we are going to then start writing the report. And finally, we are having the priority 3, which is emailing the clients. So this way we are adding tasks to our priority queue, which is called tasks, using the heap push function, and we are also giving the priority that needs for each tasks to be executed. So now I'm, for example, adding the fix bug with the first priority. So the first thing that we need to take care of is fixing the bug. Then writing the report, for example, with the priority 2, and emailing the clients with priority 3. So this heap automatically organizes tasks so that the lowest priority number, which is fixed bug here, is at the front. Okay, so first of all, it is going to be executed, and then this one, and then this one. Okay, so internally, the heap maintains order based on the priority value 1, then 2, and then 3. Now, in order to see how we are going to have the outputs and ask the compiler to print us some tasks based on their priority, we write down a while loop here to retrieve the highest priority tasks, And here we are simply printing out the tasks that are being processed. So when we are printing it out in the output, we see that first of all, we are having the fix bug with the priority 1. Then we are having the report that we need to write with the priority 2. And then we are having the emailing of the client with the priority 3. This is how we can have it done with respect to the priority level. So in this video, we learned how we can use heaps to work as a priority queue for us to have different tasks being added using the heap push function with their level of priority. So if the level of priority is lower, it means that it's the higher task that needs to be done sooner. So the lower number means that, for example, when we are having number 1, it has priority over number 2 and then over number 3, etc. until the end. Then we use a while loop to simply print based on the priority. And now here we see in the output priority 1 is first performed, and then priority 2, and then priority 3 in the output. Thank you for watching. Hi, welcome back. In today's video, we are going to use the min heap and create a min heap from a list, and then understand what are the 3 smallest elements in that heap for us. Okay? In order to do that, first of all, we need to create a min heap from the list. After doing that, we are having a list called nums, and here are the elements of the nums. Here, in order to convert this list into a min heap, we learned that we can use the heapify function. In parentheses, we write down the name of our list, which is nums. Then we print our min heap. So our min heap is like this: 1, 1, 2, 3, 5, 9, and 4. Okay? Now, in order to find the 3 smallest number in our min heap or in our heap, it's very easy to use the n smallest function. So we use the n smallest function, and in parentheses we write down first the number of numbers that we want to have. For example, we are looking for 3 smallest elements, therefore I write down number 3 here, and then we are going to write down the name of our heap, and this is assigned to a variable called 3 smallest. So it is going to assign our 3 smallest values in the nums heap and assign it to 3 smallest. Okay, and then we are printing simply the 3 smallest here heap in the output. So when I run this code, first of all, we see the min heap, and then we see the 3 smallest elements of that heap, which are 1, 1, and 2. Okay, so if we wanted to have, for example, 5 smallest elements, we could simply write down number 5 there, and we could say 5 smallest element. We write down number 5 here, and we see that 5 smallest elements that are 1, 1, 2, 3, and 4 are being printed out in the output. This is how the n smallest function is going to help us to find simply the smallest elements that we want to find in a heap in sorted order. Thank you for watching. Hi, welcome back. In today's video, we are going to learn how to find 3 largest elements in a heap. Here is my list called nums, and these are its elements. We use the heapify function to convert this list into a min heap. Okay? Then, first of all, we print our min heap. So this is the min heap 1, 1, 2, 3, 5, 9, and 4. This is how we print it out in the output. So min heap ensures that the smallest element is at the beginning, and that's it. Then in order to find the three largest elements without modifying the heap, we use the n largest function. Because we are looking for three largest elements, we write down number 3, and this is the name of the heap in which we want to find the three elements. And this is assigned to three largest. Okay. So when I run the code, we see that in the print here, three largest elements, we see 9, 5, and 4. So this n largest function is going to give us the three largest elements of the nums heap and assign it to three largest heap, then print it for us in the output. So we see that three largest elements are three largest is being printed, and then are 9, 5, and 4. So this is how we can have the, for example, three largest elements, or for example, the 5 largest elements. If I change it to 5, you see that 5 elements that are the largest ones are being printed in the output: 9, 5, 4, 3, and 2. This is basically how we can use the largest and largest function to return us the, for example, three largest elements in a heap. Thank you for watching. Hi, welcome back. In this video, we are going to show how the heap works when we are adding a new number to it, and how it can find the smallest value to put it at the root. So just imagine that this is our heap representation: 1, 1, 2, 3, 5, 9, and 4. So we are having 1, 1, 2, 3, 5, 9, and 4. This is our tree. Okay. Then we would like to add one element, and we want to add number 0 as the element. So we're going to use the heap push function, and it is going to basically insert 0 at the next available position, which is the end of the heap. Okay, the end of the heap is here, so it is going to add it here. But what we see in the output is this one. For example, is this one. Sorry, is this one. Okay, because the number 0 is the smallest element, it is going to be at the root. And when we print the heap after insertion a small number like 0, we see that the heap looks like this. For example, it is having 0, 1, 2, 1, 5, 9, 4, and then 3. Okay, but how do we get to this output? This is the final heap that we see when an insertion of 0 is done, because 0 is smaller than any other element in this heap. So this is our heap. We see that if we add 0, 0 is the smallest element here. And at the end, we are going to see this one, okay, which is like this. But there are some steps that the compiler goes through to get to this final heap that show us in the end, in the output. In order to understand, so here was my original heap. We added one number, which is 0. So 0 is smaller than the smallest element in our heap. So we are going to insert it, and we are going to insert it here at the end of the heap initially. Then we are going to have a comparison. So the comparison would be like this. So here is the list representation at the after adding number 0. So 0 is here, but 0 is going to be compared here. Okay, so 0 is smaller than its parent. Okay, you see it here. So 0 is smaller than its parent. So the parent is 3 and 0 is the child. So because it's smaller, we are going to swap their position. Okay, so we are going to swap their position. So 3 is now down and 0 is a bit one stage higher. Then we are going to compare this 0 with this one. Okay, so child is smaller than its parent, so we are going to swap them as well. So here would be the output. We are going to have 0 here, and we are going to have 1 here. Why? Because the child is being compared with its parent, and when it is compared with its parent, it is smaller, so we are going to swap their position. So when we are swapping their position, we get to this tree, and now when we are having number 0 here, and this number 0 is lower again than its parent, which is number 1. So there we are going to swap their position again, and finally we are going to reach to this final heap that we see in the output, because now the smallest number is at the root. So this is the numeric representation of our heap. So this is in the end the heap that we are going to get, but there are steps that it goes through to find the smallest element in our heap, to put it and move it at the root node 0. So it was an interesting example to see what the procedure is for the compiler to move a small element to the node 0, to the root node. Thank you for watching.